Hey everyone, and welcome to a new video on the Future Programmer YouTube channel about regular expressions in Python. In today's video, we're going to learn about regex flags, which are used to modify regex matching behaviors and enable or disable features. Let's import the re module and get started. In Python, regex flags are accessible through two names, a full name and a one-letter abbreviation. Below is a table of all the flags available in Python's re module. We have ASCII, .all, IGNORECASE, locale, multiline, and verbose. We will be discussing these four in detail because these are the more commonly used ones. To start off, let's talk about the re.DOTALL flag. By default, the dot character is a character set that includes all characters besides the new line character \n. Using the .all flag makes the dot character match all characters, so .all. So every character will be matched, including \n. This is especially useful in texts with multiple lines. So here we have a text, Python \n programming. So even though this looks like one line, this is actually two lines. We have Python on one line and programming on the second line. If we use this pattern right here, p.plus, we will see that we get Python and then we get programming, because this pattern wants to match something that starts with p and then has characters, any characters, at least one. So we want at least one character, but we cannot have any new line characters because by default, the new line character is not matched with the dot character set. So we want something that starts with p, but does not continue if it has a \n character after it. So we get Python and programming. So we get Python and all the way until here, we have \n that is no longer included in this character set, so we stop. And then we have programming, which obviously goes to the end. But in some situations, we want to match the \n character just like any of these other characters. So how can we do that? We can use the re.DOTALL flag, which we can pass in through the parameter flags. So flags is equal to re.DOTALL. And we can see now the new line character is also matched with the dot character. So our match goes from Python and goes and includes the \n character and ends after programming. And we can see whether or not I use re.DOTALL or re.s, which is the abbreviation for .all, we can see the outputs are the exact same. Now let's move on to talk about re.IGNORECASE. By default, of course, regex matches are case sensitive. So that means the words code in all lowercase and code in all uppercase and code in different casing are considered entirely distinct. In some situations, however, we do not care about whether a character is in uppercase or lowercase. In such a scenario, we can use the re.IGNORECASE flag to turn on case insensitive mode. So here we have code trying to match code with different capitalization. And we can see code will only match code in the exact same casing as the pattern. However, if we turn on flags for re.IGNORECASE, then we will see all of these will be matched because we only care about the letters and not whether they're in uppercase or in lowercase. And in this code block, we have character classes. We have a character class A to Z in lowercase with the repetition modifier plus after it. And then we have future programmer, one word, with F and P in uppercase. And we can see we'll only match everything that are not F and P. So we'll match everything that are not these two characters. So we get future and programmer. But if we turn on re.I, so IGNORECASE, using the flags parameter, we will see that we'll get future programmer, the entire word, as our match because regex no longer cares if F is in uppercase or lowercase, and the same with the letter P. Likewise, if we have a pattern of uppercase character class with the repetition modifier plus afterward, then if we try to match future programmer, by default, we will get the letters F and P, but if we turn on flags is equal to re.I, we'll get the entire string as shown right here. Now let's talk about re.MULTILINE. Now by default, the line anchor characters, the caret and the $, match the beginning and end of a string. So the entire string has a start that could be matched with the caret, and the end could be matched with the $. When re.MULTILINE is used, however, these two line characters not only match the beginning and end of entire strings, but also the beginning and end of lines. So what I mean by that is, let's take a look at this code block right here. We have regular on one line, and then a new line character followed by the word expressions. If we have the line anchor character followed by \w plus, we will see we will get regular, and that's it, because \n is not part of the character class \w, and expressions could not be matched because it is not at the start of the string as we specified here. However, if we enable re.MULTILINE, we'll see that expressions will be matched because since there is a new line character here, expressions is the start of its very own line, which could be matched with the line anchor character here if multi-line mode is enabled. And same with the $sign symbol for the end of lines. So we have regular expressions, same exact text, slightly modified pattern with instead of the caret at the start, we have the $sign at the end. And by default, we'll just get the word expressions because that's the end of the entire text. However, if we have flags is equal to re.m in our code, then we'll get both the word regular and the word expressions because regular, despite not being at the very end of its string, is at the very end of its own line because we have a new line character right afterward. So we'll get expressions by default and regular and expressions if we enable multi-line. Last but not least, we have re.VERBOSE, which allows us to write regular expression patterns in more human-readable formats. Now some, in fact, many regular expressions are very complicated and difficult to read. Here is how the verbose mode makes patterns easier to read. White spaces are ignored unless in a character class or escaped, and comments are allowed unless in a character class or escaped. So what that means is here we have a pattern. Now before we had been using the re module level functions, re.findAll, etc. We can also use flags if we define stuff with the re.compile function and then use pattern.search. Anyways, we have a pattern here. Notice the start of a raw string, and then we have 3 quotes to indicate a multi-line string. Inside of the string, we have 3 lines. However, white space, since it is ignored, this doesn't really do anything. The space between the S here and the dash here doesn't do anything. It's entirely ignored. And same with the new line between the dash and the \d. And the same thing with the white spaces, the spaces right here. Those are entirely ignored and not taken into account since these are not in character classes or escaped. Furthermore, we can have comments. So here we have a normal regex pattern, A to Z 3 times, and then we have 2 spaces followed by a comment, 3 letters. And then we have a dash, and then we have \d 4 times, so 4 numbers, and then we have a comment explaining that. This isn't particularly complicated for a regular expression pattern, but if we have a lot more complex regex patterns, then we can certainly take advantage of verbose mode to use comments to explain what we're doing and use new lines and spaces to separate the different sections of a regular expression pattern. So we have pattern and we use pattern.search abc-1234. Notice that this is one line. There is no new line between the ABC and the dash, and there is no new line between the dash and the 1234. Nonetheless, it matched just fine because we have 3 letters, as explained here, and then a dash, and then 4 numbers. What if we want to compile a regular expression pattern with more than just one flag? Say, what if we want to write a regex in verbose mode while ignoring whether letters are in uppercase or lowercase? In other words, we want to use the re.verbose flag with the re.IGNORECASE flag. Well, multiple regex flags can be combined using the bitwise OR operator, which is the vertical pipe. So here we have the exact same pattern as before, with one difference. Here we have flags is equal to re.VERBOSE followed by a vertical pipe and re.IGNORECASE. That means we don't have to have all lowercase letters like lowercase ABC. We can have uppercase A, lowercase b, and uppercase c. And despite our character class being entirely lowercase, since we have IGNORECASE flag right here, we can see our pattern matched just fine. To summarize, that is all for today's lesson on compilation flags in regular expressions in Python. Now you have learned how to enable different features of regular expressions for patterns to behave differently depending on the specific needs of your programs. If you found this video to be helpful, please consider subscribing down below. If you have any questions, feel free to ask them in the comment section. With that said, thank you very much for watching this video, and I hope to see you in more programming tutorials in the future. In the meanwhile, happy programming!